So can anybody can tell me what is the limitation of Dalton theory? Anybody? What is the limitation of Dalton theory? Anyone have remember? Dalton theory. No, Dalton. What was the first? Simply you can say John Dalton, more precisely. Na? What is the limitation? First, simply atom is, he was telling that atom is indivisible, but later on it proved that was the some major point or important point that you have to be remember. So atoms of same element are identical, but that thing is not going to be follow, especially if we talk about isobars, isotones, and what isotope. So that is not going to be hold. The same element will have same material. That's not necessary. Even it can be different. And next, yeah, that is correct. That atom combine in the form of whole numbers ratio. And limitation you talk, atom is not divisible, and atoms of same element not always to be identical in the mass. So that thing. After that, another is called what? Thomson plum pudding models that you have seen in the last class. So it is something like a watermelon, and their seeds behave like electrons, and most of the part is going to be filled with the positive ions, or we can say the protons in your word. But okay, later on that thing is proved ki okay, it is not correct, but that has been told by the Thomson. So atom model, something like a watermelon, and you have discussed a little bit about that in the last class. That after discovering the electrons, Thomson proposed that atom is positively charged sphere. That point you have to remember, it is going to be asked by whom it is said that atom is a positive charge sphere. It has been told by the Thomson. That question has been asked once. Electron are embedded into it like a region of a puddings. Yeah, that's what it's called plum pudding model. First model to introduce subatomic particle. Yes, that I have highlighted. You can see, you have to be remember, because before that no one had talked about that about the subatomic particles. Everyone was considering that atom is indivisible, it cannot be divided. So first time Thomson talked about that subatomic particles by the discovery of electrons. She talked about that. After that, shifted idea for indivisible atoms, because they already talk about the subatomic, so obviously it will be divisible structures. And yeah, laid the foundation of future atomic model. So sometimes question is also going to be asked, who is the father of the atomic model? So that credit also goes to the Thomson, right? But if we talk about limitation, so last class we have seen first limitation. It's not going to be proof the Rutherford gold foil experiment. What is Rutherford gold foil? Now after 2 minutes I will discuss about that. After that, they haven't anything given explanation about the nucleus. No explanation they have given. They have just told it is a positive sphere and the electron is embedded in that like a seeds of the watermelon. So simple they have told. They never talk about the nucleus. But even earlier to that, nucleus was known. Earlier to Thomson, nucleus was known, but he haven't talked anything about the nucleus. So that is one of the limitation of that one, Thomson model. Yeah, field scattering of alpha particles. This is nothing but this is the extended part of that. Both are the same thing. This is extended. Rutherford gold foil. Actually, they have centered the alpha particle itself. So both are the same thing. And yeah, could not describe the atomic stability, how the atoms are stable. They are not able to explain about that thing. So that all are the limitation. And yes, my dear friends, whatever point is here bold, try to remember that point, because I have bold only that point which has been asked in different exams. So at least the point which has been bold now, try to remember that. Okay, now we'll last class we have discussed all that in the last class. Just I recall all that. Now today onwards I will start the Rutherford nuclear model, important, and their contribution is really good in the field of atomic theory if you talk. After that we'll talk about the wave nature also in today's session. So Rutherford nuclear model. Rutherford performed the gold foil experiment. That was one time question has been asked in one of the exam. Gold foil experiment is done by. Simple question was there. Gold foil experiment is done by Thomson, Rutherford, Dalton, like that. Goldstein, like that. The option was there, like that. So always keep in mind Rutherford have done the good foil experiment. How this thing has been done? So here we can see, my dear friends, that is something like here it was something rays, alpha rays is coming from that, and it is going to be a strike over the nucleus, or not even nucleus. It is going to be, suppose this is one of your atoms, now this is nothing but this is your atom. On that atom, alpha particle has been scattered, or alpha particle has been projected. And after that, here we can see the different things I have seen. Here we can see, if the alpha particle is goes, you can see this rays is not reflected, this rays is not reflected. Why? When rays will reflect, if anything would be there, then if you go in the space, my dear friends, you might have seen it is dark, very dark. Why? In the space nothing is there, so light is not going to be reflected now. So if it's not going to be reflected, how I can see? Simple phenomena, how you can see anything. When the light is going to go on that, and after that it is reflected back to our eye, then I am able to see, right? But if suppose if there is nothing, if you go in the space, in the space, if you are going, nothing is there. So nothing is going to be reflected. So it is totally dark, right? Same thing is happening there, my dear friends. Since that part is vacant, if you talk about atoms on which alpha particle is coming, so you can see it is not reflected, it is not reflected, it is not reflected. Yeah, few is reflected. So what the conclusion in that means most of the part of the atom is vacant. Why? How you are getting? Because they are not going to be scattered the light, reflected the light. So in that point, first time Rutherford is goes wrong, because he was telling no, it is filled of positive ions. So he is telling how it is totally empty there, because alpha particle is not reflected back. Yeah, little bit. So that thing you have to be just keep in mind. So what the observation we can see? Observation we can see here simply written. Most alpha particle pass straight through. It is not reflected, right? So what is the meaning of that? A few it get reflected and very few is bounced back. Conclusion, most of the atom is empty space. Why? Because it is not reflected. So conclusion that most of the atom is empty. That is the another important point, has been asked in one of the exam. I don't know, because in every exam some question has been asked. Question is that by which experiment it is found that at most of the part of the atom is vacant. So that is gold foil experiment done by the Rutherford. Okay. Another conclusion that we can see, because few got is deflected or reflected, so positive charge and most of the mass are concentrated in a small region called nucleus. Now see who have defined well done about the nucleus. So my dear friends, that was the Rutherford. That's why sometimes it is said that who is father of nucleus, then the answer will be the Rutherford, right? Because they have given first time about the clear pictures about the nucleus. Before that no one have given the clear picture about the nucleus. So he have defined, okay, positive charge and most of the mass are concentrated in small regions. Why they have told? Because he have seen this is one of the small regions in which whatever rays are going to, this is reflected back, totally reflected back. So some parts is fully solid, and this part is called nothing but it's called is what? Nucleus. So always keep in mind that point. Also going to be asked, who is the father of the nucleus, or sometimes like that, who discovered the nucleus. So that credit goes to which one? Rutherford. Even you can see everywhere. Here also we can see, the rays is going to be, and it is reflected back like that. So that region you can say is nothing but nucleus. So positive charge and most of the mass are concentrated in a called nucleus. Electron revolve around the nucleus, but they have given one new concept. Okay, electron is going to be revolve around the nucleus, right? Before that, you talk about Thomson. Thomson not talk anything about the electrons, right? They have just told it is embedded like a seeds or plum seeding model, something like that. But he is telling no, it is nothing like that, because already Thomson has goes wrong, because most part is cavity, most part is space, most of the mass is concentrated at a small, very small region called nucleus. And after that they have told, you know, electron is not in the static condition, my dear friends, it is revolving, it is going to be revolve. So revolve around the nucleus, that has been told by the Rutherford. Now, yeah, whatever I have told, the key observation, even if you can see, second time I repeat, alpha particle pass through a straight line, means state, atoms is most simply somewhere deflected, so presence of positive charge, very few reflected back, existence of dense nucleus, discover of nucleus as I have told you. Okay, now what is the limitation of that equation? My dear friends, do you know? If suppose he is telling that electrons is going to be revolved around the nucleus. So suppose this is the nucleus. So electron is going to be revolved in that path, right? So what should happen, my dear friends? If electron is going to be revolved, then obviously they need some energy, right? Without energy, nothing can revolve there. They need energy. So Rutherford was totally failed to describe why it is going to revolve in a circular path, how they are getting the energy. So they were not able to explain. They have just told, okay, it is revolve, but why? How they are getting the energy might be possible, my dear friends. If the energy is decreasing, suppose anything is going to be revolve and their energy decreases, so what is happening? I have come with some diagram. I think here we can see something could be like that, huh? Electron is going to be revolved, since no one is going to be supply the energy. So what is happening? Ultimately they will come and going to be collide with the nucleus, and it will be the dead for the atoms, but actually it is not going to be dead, huh? So here we can see that is one of the drawback or major drawback of the Rutherford. He was not able to describe how the electron is going to be revolved around the nucleus. Simply they have told. So after, when another scientist came, they think, okay, if they are going to revolve, they must have something who is going to be provide the energy to the electrons. So they haven't defined which is going to be support the electron. If it is not able to describe, so the conclusion came according to that this is going to be revolved like that, and ultimately they will come and strike with the nucleus, and it will be the dead state for the any atoms. But actually it is not happening. So if you talk about limitation here, so here according to classical physics, revolving electrons should lose energy obviously and fall into the nucleus. But atoms are stable. Why we have seen atom is stable? It is not going to be dead state. So Rutherford could not explain this. It was not able to able to explain this. Now after that another people came. So my dear friends, that is one of the conclusions that you have to be keep in mind, huh? Every model I have given just for my dear friends, just for one view you could be able to remember everything. If you talk about features, huh? So structures, some Thomson model, positive sphere with electron embedded. But if you talk about Rutherford model, he told central nucleus with orbiting electrons. Space in atom, no empty space. Why? Because they have told more, whole sphere has been filled by the positive ion, so no empty space. According to that, mostly are the empty space. If you talk about nucleus, so according to Thomson, they haven't talked anything about the nucleus. So he's telling, okay, no nucleus is there, but he talked, yes, nucleus is present. Basic electron discovery, he has talked gold fire experiment. So if you talk about what is the flow chart of atomic model, so first came Dalton Sahab. They have little bit given their contribution, but yeah, that was the first step. And in anything, first step is more crucial, my dear friends. Even if you start your preparation, then what is your first step? To purchase your batch. That is one of the crucial decision. That's why it is said that most of the credit goes to the Dalton, because they have taken the first step in the discovery of the atomic model. So first Dalton, then Thomson, and after that Rutherford. But the Rutherford have major drawback about the electron is going to be revolved. So ultimately they will lose the energy and come and collide with the nucleus. So they are not able to explain that. So after that another people came. The name is what? Bohr. What the name? Bohr atomic model. So now I will discuss about the Bohr atomic model. Now before moving to the Bohr, first I want to ask, till now everything is cleared or any doubt anyone have, then ask, then we'll move.
Sir, you said about the alpha particle, right? Uh,
Right.
What is alpha particle?
Alpha particle is something like a positive ions, dear, right? It is
Okay,
something like a positive.
which alpha particle Rutherford used in the experiment?
What?
Which alpha particle he used in the experiment? Like which positive ion or alpha particle he used?
No, no, positive. Alpha particles you look at a positive ions, and there it is something like a helium atoms. Helium, okay, something like a helium mass is
Helium.
twice,
Okay.
like that.
Okay.
Look
Thank you.
like alpha particles. Clear now?
Yes.
Okay, so now I think everything is clear. Now we'll move next. That is what Bohr atomic theory. So please try to remember all that. We'll see all that in the question part. Now, if you talk about Bohr, yeah, their contribution is good, and even on their contribution, currently we are working. Okay, it is old now because now you are talking about the wave nature, not about the particle nature currently. So improve Rutherford model and propose a theory mainly for the hydrogen atoms. Keep in mind that is the only key point most of the time question has been asked most of the time. कि Bohr's atomic theory is applicable mainly applicable for hydrogen, helium, nitrogen, carbon, like that option you can get. So always keep in mind Bohr atomic theory is mainly deals with the hydrogen atoms. Now tell me, if you talk about hydrogen atoms, how many isotopes of hydrogen atom have? Can anybody can tell me? Have you remember? Huh? Yeah, read the PDF. Three na? In hydrogen. In hydrogen, how many neutron is there? In hydrogen atom, simple hydrogen atom, how many neutron is there?
Zero.
Zero, right? Please read all that. That all the basic point here. And you expect the question like that. If you go through your previous year question, na, only one or two question left out of 24 or 23 question. Only one two question are tougher. All are the very basics question. And because it is not going to be select the PhD people, right? They are just going to select the diploma or BTech guys. So simple question they are going to be asked like 11th, 10th, 11th level. Hmm? So keep in mind that thing. Bohr atomic model basically given for the hydrogen atoms, and they have little bit overcome the problem of Rutherford also, that also I will see. So Neil Bohr improved the Rutherford model and proposed the theory mainly for the hydrogen atoms, that you have to be keep in mind. What the theory tells, if you talk about so Bohr's atomic model, now they came about the orbital. We can see just diagram. I will come on that. This is called n orbital, m orbital, k orbital, l and k orbital, and something this is like that. Okay. Now first come to the their theoretical part. What you can see, electron transition. Okay, my difference always. Okay, I will come on that. Before that, let's complete their theory. Electron revolve around nucleus in fixed circular path. This path is called orbit or energy level of cells. So first thing, electron revolve around the nucleus in a fixed circular path. These paths are called orbit or energy level of cells. Each orbit has fixed energy. As long as electron stay in a particular orbit, it does not lose or gain energy. So Bohr came and he told no, because Rutherford talk okay, electron is going to be just revolve. So after that, yeah, very common question came, if they are going to be revolve, so how they are getting energy? Other ultimate they will come and collide with the nucleus. So Bohr came and he is telling, no, my dear friends, the story is not like that. If you talk about, he is telling that electron stay in a particular orbit and it does not lose or gain any energy. Always it is in the one particular orbit, and in that orbit when it is going to be revolve anything, they are not going to be lose any energy. Their energy is always fixed. So again people came and they start asking, that means electron will not change their cells? So he told, no, they will change, but once you supply the energy, once they will lose the energy, then they will change their orbit. Otherwise they will revolve. If in no change in any energy, they will continuously revolve in a fixed orbital. They will not change their orbit. So here we can say, see, as long as electron stay in a particular orbit, it does not lose or gain energy. Electron can jump. Yes, it can jump one orbit to another. When electron will jump? When we can say from lower orbit to higher orbit, when energy is absorbed. Electron will goes from lower orbit to higher orbit when energy will be the absorbed by the atoms, and from higher orbit to lower orbit when energy is emitted, or we can say lose. Even emitted we can say lose. So always keep in mind that point is also going to be asked. Sometimes you find in the exam from lower orbit to higher orbit. Here we can see the orbit here. Here just diagram I have given you. Okay, here we can see the orbit, like that. Now different orbits is there, and if you talk about they will come. Here we can say change. If the energy will change, they will come and they will go one orbit to another if energy is supplied or used. So that thing you have to be keep in mind, from lower orbit to higher orbit when they will absorb the energy, or from higher orbit to lower orbit electron will goes when it will emit or lose the energy. Load means they are going to be use some work for, you are going to use that energy for certain work. Angular momentum is quantized. Angular momentum is always quantized, and angular momentum of electrons, because it is going to be revolved here, right? So revolving is what? Angular or linear? If you talk about Motorola, Madhu, right, Nagarjun, Shiva, Parveen, Rohit, Sanjana, Sarvnath, Bineet. Huh? So if I will ask, what if anything is going to be revolved? Obviously you talk about the angular velocity, angular acceleration, angular momentum. So he talk about angular momentum of electron is given by, keep in mind, mvr equal to nh upon 2 pi. So remember that, because not in all the exam, but sometimes they are also going to ask what is the angular momentum of the electrons. Very simple straightforward question. What is the angular momentum of they will not talk about any model. Simple, they will talk what is the angular momentum of electrons, and some option will be the given. So always keep in mind it will be nh upon 2 pi. So what if you talk about m is the mass of electron, v is the velocity, r is the radius, n is the principal quantum number. N is what? Principal quantum number, and h is what? Planck's constant. So what you have to be keep in mind? You have to be keep in mind mvr equal to, tell me everyone, nh upon how many pi? 2 pi. Okay, nh upon 2 pi. So tell me one thing, are you guys are going to appear in HPCL also or not? HPCL exam? Have you filled the form of
No,
HPCL?
no,
Any?
sir. No, sir.
Okay.
No, sir. No, sir.
Okay, okay, no
No,
problem.
sir.
Because I think your age is, more than the required. That's why, right? Are not interested. Yeah, golden opportunity, no? Okay, no problem. Most of the students have filled. Even in the, when I talk in other batch. Yeah, yeah, I think their age should be less than 24, then only you are eligible. And in your exam, what is your age requirement of your exam? I think 40 years, right?
Yes, sir.
Maximum.
45 years also for category students.
Okay,
If they have some
general I
regulations
talk.
also.
General I talk. 40, na?
Generally, it's 40, sir. 44 is so.
Okay, 44.
Yeah, they have extended, sir.
Yeah, and that means parents and their child both will appear in the exam. Huh? Okay, that's good. Well, so why I'm telling that question has been asked in HPCL. That's why I've told. Same question, in HPCL, I think electronics branch was there or electrical. Exactly, I'm not able to recall. That question has been asked. Angular momentum of electron is given by, simple question was there. That's why I asked about that. Okay, so I will keep in mind. Now, if you talk about cell, so Bohr named the cell K cell when n is equal to 1, L cell n equal to 2, M cell and N cell. As the value of n increases, you can see value of n increase, what will be the radius? I should it will be better if I will. Okay, you can see if the value of n increases, we can say the orbit size, that means radius is also increases, energy will also increases. Here we can say as the value of n increases, radius increases, energy increases, electron further from the nucleus. Yes, even you tell me, my dear friends, you think, tell me, suppose if you talk about very simple thing, you don't have to be remember. You now tell me if you talk about k orbital, k, right? So here electron have to be revolved in a smaller path, right? In that. But if you talk about L, they have to be moved on a certain more circumference. If you talk about m, more circumference. If you talk about n, furthermore. So just tell me in which orbit more energy is needed. Anybody can tell me? More energy will be there in which m, n or kl. Obviously, if the electrons revolve on that, they required more energy or no, my dear friends? Required or no? Tell me. If so, that question is also going to be asked. And since you know the electron which is going to be revolve in that, they have more energy. They will come in that when they will use the energy. They can go in that if they will get the energy. Simple thing, not tougher and not a rocket science is there. Very simple, because if anything is going to revolve at a higher radius, obviously they require the more energy, right? Okay, see, that question very less going to be asked, but just for being safe now, I had recommended you try to buy her that. Try to buy her. Okay, less time going to be asked. So why you have to be take any types of risk? What is the Lemon series, my dear friends? The question asks in Lemon series what is happening. So we can say in the Lemon series, electron came in the first orbit. From where? From any orbit. If the electron will come in the first orbit, that is called Lemon series. So sometimes straightforward question is going to ask, what is Lemon series? In Lemon series, lemon, right? In Lemon series, electron come in the first orbit. That is the meaning of Lemon series. If you talk about Balmer series or Balmer, whatever you can pronounce, Balmer or Balmer. So in that, what is happening? Electron is coming from any other orbit, escaped one and goes in the second orbit. That is called is what? Balmer series. Pastian series, this is called Pastian series. When electron come from any orbit to the third orbit, then this is called Pastian series. And what is bracket series? If electron come from any orbit, higher orbit to the fourth orbit, that is called bracket series. Sir, that question has been asked? No. Very rarely, in the IIT JEE sometimes that question has been asked. But in that simple exam, I haven't seen that type of question. Just for being safe, I have given that data. If the electrons come to the first orbit from any higher orbit, if they are coming to the first orbit, then that type of series, because there's infinite number of electrons here. That's why we talk about the series, not a single electron. Infinite number of electron is there, no? So that's why it is called series, and this is called Lemon series. Okay, if they are going to the second orbit from any higher orbit, not lower, so this is called Balmer. If they are coming to the third orbit from any higher orbit, then that is called Pastian series, and that is last. If coming to the fourth orbit from any higher orbit, then it is called bracket series. First of all, tell me, have you remembered that? Remember? Hello, हेलो. नहीं, आप थोड़ा क्लास में तुम क्लास से फ्री वर्क करे छो. Okay, clear now? Tell me clear. What is bracket series? Anybody can tell me? That not necessary. Okay, I have just given. If you talk about hydrogen atoms, energy in nth orbital minus 13.6 upon n square electron volt, and minus is sign here. Energy is negative because electron bound to the nucleus. Lower the value of n, more stable orbit, obviously, because they have less energy. Anything have less energy will be more stable. Why you are if anything anyway energy is increasing, na stability decreases of anything you talk. Because they will start spinning, they will start rebounds to another orbit. That's why less the energy, more will be the stability. And same way we can say less acquired, more will be the happiness. Right or no? Desired, sorry. Less desired, more will be the happiness. Less energy, more will be the stability. So n is equal to 1 is the ground state. Higher n value correspond to the excited state. That formula no need to remember dear. But just now I have given that thing, but not that much important. Simple thing here we can see if they are going to be change their orbit. Arey yaar. Energy obviously when electron move from one orbit to another, energy difference is E2 minus E1 simply. This energy appears as a radiation and this radiation is given by h nu. H is Planck constant, nu is the frequency of the radiation. So that energy whatever they are going to be resolved, irradiated, then they will change their orbit. Merit of Bohr's model, obviously they have talked about the stability of atoms. So sometimes that question is also going to be asked. First time who described the very well about the stability of the atoms, then what will be answer? What will be answer? Then answer will be the Bohr model. That question has been also asked in some exam earlier. Which theory first of all talk about the completely or given the full proof theory about the stability of atoms. So this is Bohr theory who have described very well about the stability of the atoms. Earlier that you talk about Dalton, you talk about Thomson, you talk about Rutherford. No one have explained very well about the stability of the atoms, but they have proof about the stability. Explain the hydrogen spectrum. Hydrogen is nothing but talk about they have just given the theory for the hydrogen atom, introduce the idea of quantized energy level, gave mathematical basis of the atomic structures, like that. Limitation of Bohr model. So if you talk about Bohr model, mainly applicable for the hydrogen and hydrogen like species. Okay, so limitation is what applicable mainly for the to the hydrogen and hydrogen like species. Fail to multi-electrons atoms. They will fail if we talk about multiple electrons atoms. Could not explain the fine spectral lines. That not important. Okay, that is the IIT things. Not necessary. Could not explain Gemini effect and a Stark effect. Assume fixed circular orbit which is not fully corrected according to the modern quantum mechanics. He talk about the fixed circular orbit, that is also not right according to quantum mechanics. Now I will discuss about the what is the quantum mechanical model of atoms. Whatever till now we have discussed here, that is wave nature or particle nature. Electron is here like a wave or particle. Tell me everyone here, this is like a particle, na dear? It is not like a wave. Whatever till now we have discussed either about the Dalton law, Rutherford, Bohr, Thomson, they all treated electrons like a what? Particles. But in the modern, if you talk about quantum topic, here I will discuss about that. Okay, it is not like a particles. It behaves like a wave. Okay, so that thing now we will discuss. Here we can see the quantum mechanical model of atoms. That is the modern technology that you are going to be used. So modern atomic theory is based on the quantum mechanics. It does not describe electron as a moving in a simple circular orbit like planet. I know if you talk about the planet, so it is simple going to be revolve along some circular orbit. Okay, it could be elliptical orbit also, but it is going to rotate along some fixed orbit. So it is not like that. So modern atomic theory is based on the quantum mechanics. It does not describe electron as moving in a simple circular orbit like a planet. Instead, it describes the probability of finding an electron in a certain region around the nucleus, and that is the key point of the what modern atomic theory, we can say, even quantum mechanical model of atom, you can say. What the currently, before that, whatever you have told, in every way it is assumed that electron is a particles, not even electrons, whatever you talk about as electrons, proton, neutron, consider as a particles, right? But in the modern, it is said that it is not like that. Okay, it was telling na ki this is the orbit and there will be the electrons, but they are telling no, that not necessary electron will be there. I can find the probability. What is the probability that electron is there? I will find the probability. I cannot say exactly what the location of that thing. That is the first thing going to be talk about the modern atomic model of the atoms, or atomic model modern, in which you talk about the quantum mechanics. In the quantum, you talk about always you talk about the probability of getting anything. In the if you talk about more, if you talk about earlier, so it was telling okay, it is there, fix is there, probability is 1. But according to quantum mechanics, he is telling that not necessarily electron will be there. If you talk about de Broglie wave, after 5 minutes I will discuss, we can see I am not able to sure about their position, I will get their probability. So always keep in mind, my dear friends, if you talk about quantum mechanical model of atoms, so it describes the probability of finding electrons in a certain region around the nucleus. Okay, and this model developed from the various work done by the de Broglie, Heisenberg, Swangel and Pulley, whatever you can pronounce. De Broglie wave you might have listened. Heisenberg, Heisenberg, Schrodinger, Schrodinger, or Pulley. So first to talk about the de Broglie concept. What the de Broglie have told. So de Broglie suggests that matter has also wave nature. Wave means continuous. Wave means continuous. Like rays is coming to me. So it is continuous, or it is in the discrete form. Later on, both thing is going to prove same thing. Both are the same. Even sometimes that can be treated as particle wave, particle natures. Sometimes they can treat it as wave nature. In the wave, what is happening? Suppose this is, so this is like a wave thing. If the range is going to be like, so it is called wave. This is called is what? Wave. So if you talk about wave, they must have some frequency. So here you are going to be talk about de Broglie suggested the matter also have wave nature, and lambda is given by h upon m and mu. Here lambda is wave nature of the particles, and this is nothing but lambda is called wavelength. As I talk, if you talk about any wave, so you talk about the wavelength. This is nothing but this is the consecutive distance, dear. So from there to there, this is called their what? Lambda. This is wave nature. So gap between those consecutive, either you talk of peak and trough, this is called 2 also. So from there to there, this will also called lambda. Okay, I'm going to make by the hand, so sometimes look like okay sir, this is less distance, that is more, but exactly it will be the same. So here you can say lambda, it represents the wave nature of particle like electron, proton, etc. It tells how the particle behave like a wave. Next we talk about h is Planck's constant. You don't have to remember the value because it is not going to be asked. And m is mass of the particles. Heavier particle have a smaller wavelength. V is the velocity, speed of particles in meter per second. Faster particle have shorter wavelength. So all that you have to be keep in mind. What the main thing, sir? What I have to be keep in mind, that what the de Broglie wave suggested. So that is the very important, and several times that has been asked in different exams. So that you have to be remember. How they have given, that not our concern. They have given just by proof. They have some, my difference. If you talk about anything and you have to prove, so basically there are two types of proof of anything. One is mathematical proof, another one has experimental proof. So if you talk about, so what is the proof of that, my dear friends, it don't have any, mathematical proof. It have experimental proof. So whatever you talk about, modern, atomic, you talk about the quantum mechanics, most of the thing have, experimental proof. Yeah, they have, some have the mathematical proof means you are going to given the mathematics equation and equation 1 to LHS RHS same like that you are going to do. So that is called mathematical proof. But अभी कितना बार फोन करेगा once. But if you talk about experimental proof, in that, not any mathematical proof. Like I will tell you, tell me, if you are from the engineers, 9 or 10th class, you might have been taught that heat is going to flow from high temperature to low temperature, right? Heat is going to flow from high temperature to low temperature. Yeah, I am right. Heat is going to flow high to low. Can anybody can tell me what is their mathematical proof? Have you seen ever? Anyone, have you seen mathematical proof of that? Okay, heat is going to flow from high to low. No sir. How you are getting? Yes sir, I have experimental proof. So experimental, I will experiment, I can check. Okay, heat is going to flow from high to low temperature. I have only experimental proof. Same you, my dear friends. If you talk about that, they have experimental proof. They have seen the relation by using various, instrument and all that. It is not that much of easy. Otherwise, I will also prove something and it will come on my name. So they have put lot of effort, and after that they have given lambda is equal to h upon m mu, m v simply we can say. So lambda is wavelength, h is Planck's constant, m is mass, and v is the velocity. Even here we can also see, my dear friends, mass will be the high for a given condition. What will be the wavelength? It will be the, dear, tell me, less or high? It will be the less. So one time, I think that was the Rajasthan question I have seen. In Rajasthan question was that according to de Broglie concept, if the mass of the particles is going to be increased, or when wave is going to be increased, what will be the wavelength? That was the question. So it will be decreases, dear. If the velocity increases, what will be the wavelength? It will be decreases. So that thing here we can say relation. You have to remember, mass of the particles, heavier the particle, a smaller wavelength will be there. I have highlighted that point because it has been asked one times. Similarly, a speed of the particles, faster particle, shorter wavelength. Okay, shorter wavelength, and always keep in mind which one have more energy, my dear friends, shorter wavelength or higher wavelength? Tell me everyone, dear, which one have more energy? So we can say, sir, just assume kinetic energy is what, sir? Half mv square. Half mv square. Sir, if mass is high, velocity is high, kinetic energy will be high. But if velocity will be high, na sir? If mass will be high, velocity will be high. In both the case, I can see lambda will be the less. Right? So my dear friends, shorter the wavelength, more will be the energy. Always keep in mind, shorter the wavelength, more will be the energy. That means that wave propagate a longer distance. Keep in mind always, whenever any wave have shorter wavelength, the meaning is that they can travel a more distance. But if any wave have higher the what wavelength, the meaning is that they will propagate a comparatively less distance. So always keep in mind, any wave have high energy, the meaning is that their wavelength is less. Any wave has low energy, meaning is that their wavelength is what? High. Tell me, till now every story is cleared? Tell me, till now every story is cleared? Hmm? Hmm? I'm telling one thing, if you talk about even earlier that I have completed material engineering material in one of the batch, that was I think AEE, Assistant Environmental Engineers, that is also Andhra Pradesh batch. I have seen here also was very less interacting with the educator. I don't know what the problem like that with the Andhra Pradesh student. Even in the same in this batch also, only I am going to speak. When even I am going to ask, tell me anyone have any doubt or the thing is clear, still you are not going to be respond. Tell me what the issue here? Huh? What is the issue? Parveen and everyone, why you are not going to respond? Okay, let's assume you are not, you are sitting in the library or anywhere. You can chat itself now. Otherwise, it will looking like I am just going to record the session, and it will be very boring session. Huh? So try to interact. If you are coming the live, talk, let's discuss, dot ask. Okay, if you have no doubt, no problem. Still once I ask, na, okay dear, then clear. You must have to respond dear, na. Huh? That is the advantage of live class. Otherwise, could be possible. I will just sell the only recorded lesson. I will record and it will be very easy to me. Why? Because no one is asked. Just come and elaborate and go. Hmm? So try to try to discuss
Yeah,
the thing.
clear, sir. Actually, we are interactive. It's clear, sir.
Huh? Okay. Really, I'm telling you. Earlier that you don't know, one institute was there, Gate Forum, ACE Academy. If you have known about that, 2 years I was in the Hyderabad. But in the offline, the guys are going to ask a lot of questions. But once they come to the online, now very shy people they became. But don't be like that. Okay. So I think till now everything is cleared. Okay. Now come to the next concept, that is called Heisenberg uncertainty principle. Why uncertainty? Because they are not certain. That's why. What is not certain, sir? The position is not certain. That's why it is called Heisenberg uncertainty principle. Heisenberg uncertainty principle. Okay. So why it is called Heisenberg uncertainty? As I told you, dear, as I told you, it is impossible to determine simultaneously and exactly the position of electrons and the momentum of electrons. It is impossible to get the what is the position and what is the momentum. That's why we can say it is going to be given by delta x into delta p is equal to h upon 4 pi. Delta x into delta p is equal to sorry, not equal to, greater than equal to h upon 4 pi. What is delta x? Delta x the uncertainty in the position, because you have just talked now, just talk what you have just talked ki sir their position is not fixed na sir, I will get that probability. So delta x uncertainty in the position. If you talk about delta p, this is uncertainty in the momentum. H is what? Planck's constant. So this is uncertainty in the position, this is uncertainty in the momentum. Now little bit come in the more deeper. Here we can say delta x, delta p, for the limiting condition we can make is equal to x. So delta x is what? Position uncertainty. Delta p is what? Momentum uncertainty. So my dear friends, see, if delta x increases, see, if delta x increases, yeah, decreases, let's assume delta x decreases, if you can pinpoint the position of an electron, delta x is what? Position, then you cannot know its momentum. If I am going to be specify the location, then it will be difficult to find their momentum. But once, if I am going to be fix the momentum, if you know the momentum of the electrons, we cannot locate their position, right? Because delta x increases. So if you talk about delta x into delta p is equal to something constant. So one increases, obviously other have to be decreased. Once increases, other we have to be decreased. If that increases, that have to be decreased. So if you know the momentum of an electrons, you cannot locate its position. It will be very difficult, and that's what is called uncertainty principle. Heisenberg uncertainty principle. Clear? Here we can see simple things, and sometimes it is said that simple things is always complicated. You cannot say exactly where the electrons and how fast it is moving at the same time. You cannot say where the electrons and how fast it is moving at the same time. That's why this idea is fixed orbital is replaced by idea of an orbital, which the region is high probability, and the exactly when electron is and how fast it is moving at the same time. You cannot know exactly where the electron and how fast it is moving at the same time. That's why idea of fixed orbit is replaced. And why? Now next idea which is coming, the region to finding the electrons, their probability have to be find, right? So because of this idea, fixed circular orbit is not corrected of electrons. Instead of that, electrons are found in orbitals. Now what is orbital, sir? So orbital is the region where the chances to getting the electrons is the more, and that region is called orbital. So here we can see which are region in a space where the probability of finding an electrons is maximum, and this is called nothing but called orbitals. So what is orbital? So this is the regions where in the space obviously where the chance of the finding of the electrons is the high, and as well as their momentum will be the less. So my dear friends, I think I have completed the things. Here we can say the Heisenberg uncertainty principle, position of electrons, momentum of electrons, delta P, all that things we have seen. Delta X is uncertainty, and delta P is uncertainty momentum, X is Planck's constant. Here we can say just I have given, and that all about the today session. Now when we'll meet in the next session, I will start the Sondigal wave equation, and after that I will come to the question part. Here we can see lot of question. So today time is not allowing me to continue the session. So that's all my dear friends. When we meet tomorrow, I will come with the question part and some theory is left. All that I will discuss in the next class. Now it's your time. If anyone have any doubt, we can ask. Otherwise, thank you for today to listening the session such a huge patiently. Even going to respond also some questions. So we'll meet tomorrow. Now, anyone have any question?
Sir,
Yes, sir.
what is the use of finding an electron, sir? Why should you find an electron? Basically,
Sir, can you send the note, Sanjana? Yes, I will send here. Even yesterday I have also sent. Now one of my friend is going to be asked, sir, why it is necessary to find the region of electrons? If you are not going to find the region of electrons, so it will be very complicated to find the what will be the nature of the chemical reaction. You cannot able to detect, you cannot able to find what is the reaction. In the last class I have told you what the electrons basically going to be do. So that is going to be take participate in the chemical reactions, and chemical property mostly going to depends on that. So if you are not able to find that, you are not able to get the exact chemical property. Another thing we can also say, since here we can see in the atoms you talk, it is something like going to be work like a wave nature. So wave nature if you talk about, so you have to be must known what is the position, so that it will be easy to calculate the lambda energy and all that. Otherwise you are not able to find the energy also. So it is a most important here to find the what is the location and what is the position, what is the momentum of electrons, all that. That's why it's important to us. Not even in engineering, even if you have to be talk about the electrical engineer, all that, they everything is based on the electrons position, right or no? So all that condition, it is necessary to get the location of electrons. Clear, dear?
very clear, sir. Thank you, sir.
Okay, so that all about today's session. We'll meet in the next session. Thank you all.